In this example, we're going to look more at prime and composite numbers. Specifically, we're going to practice verifying that a number is a prime number. So verify that the following numbers are prime by checking to see if the number is divisible by any prime numbers whose square is less than the number given. So that last part is really a mouthful, but once we see how useful this piece of information is in minimizing the amount of work we need to do to check to see if a number is prime, you'll see that it's worth it, and we'll make sense of it in the context of this problem. So we have 89. So we said if we wanted to find all the factor pairs of 89, we only had to check up to, well, 89 lies between 81 and 100, so we would have to check up to 9. So let's just write that here. We would need to check up to 9 for factor pairs. So that was the case when we wanted to find all the factor pairs of 89. Okay. So in this case, we're not looking for factor pairs in particular. We just want to see if this is prime, is it divisible by any number by 1 in itself? So we know that 89 is 1 times 89. Okay. Now let's start checking all of these numbers up to 9, but we're going to look at some patterns. So we see that as the directions say, we only have to check any prime numbers whose square is less than the number given. We're not actually going to need to check all the way through 9. So we know 89 is 1 times 89. Okay. Now, is 89 divisible by 2? Well, it's not even, so it's not divisible by 2, but we could do a calculator check. Divide by 2. There's something after the decimal, which is equivalent to having a remainder, so it's not divisible by 2. Now let's check 3. Well, if we divide 89 by 3, we get a remainder, or we get a decimal, which means there is a remainder, so it is not divisible by 3. Now, let's think about what would happen if we checked 4. Well, 4 is a multiple of 2. Okay? So if a number has 4 as a factor, it must have 2 as a factor. So let's write that out. If 4 is a factor of 89, 2 must also be a factor of 89. Okay? And that's because 4 is 2 times 2. So we could think of 4 as 2 times 2 times some number if it were a multiple of 89. Okay? So here's a 2. This would be the corresponding question mark here. So we don't have to check 4. Okay? We could check it. We'll double check it. Only takes a second. Notice we have a remainder, and that's what we'd suspect. Okay. Now let's check 5. So we can see 89 doesn't end in a 0 or a 5, so it's not going to be divisible by 5. But we just verified that. There's a decimal, so there's a remainder. So it is not divisible by 5. Now, next we would check 6 if we were finding factor pairs. Okay, we're just checking to see if it's prime or not. Now notice, just like with 4, if a number was divisible by 4, it would also be divisible by 2. Well, 6 is 3 times 2. So, if 89 was divisible by 6, it would have been divisible by both 2 and 3, because we have the 2 and 3 here. And we know it's not because we already checked 2 and 3. So notice the pattern that's starting to appear here, which is what this piece says. We didn't really need to check 4 or 6. So since we're not looking for specific factor pairs, we're just looking to see if it has any factors. Okay? Both of these would have been caught at 2 and or 3. If it did have 2 or 3 as a factor, it would, if it did have 6 or 4 as a factor, it would have necessarily had 2 and or 3 as a factor. Okay? Now 7 is next. Okay? And 7 doesn't have any prime factors less than it. 7 is a prime number. So we'll divide by 7. And we see there's a remainder because there's a decimal. So it is not divisible by 7. Okay. Now check up to 9 for factor pairs. Now again, we could check 8, but 8 is 2 times 4, or 2 times 2 times 2. So if it was divisible by 8, it would have had to be divisible by 2 or 4, and we already saw that wasn't the case. Okay. I'm just going to verify these once. 89 divided by 8. Right. Decimal means it has a remainder, not a factor. And now 9. Well, if it was divisible by 9, 9 is 3 times 3. Then it would have been divisible by 3 as well, and we already saw that 89 is not divisible by 3. This last time we're going to check just to verify, and notice there's a remainder because there's a decimal, and it's not divisible by 9. So notice what happened, okay, is we found that it doesn't have any factor pairs up to 9, which is how far we had to check, so we know now that it's prime. Okay? But even more than that, we didn't need to check 4, 6, 8, or 9. We checked them just in this first example just to verify why we didn't have to check them. And the reason is that they had a prime factor which is going to be less than itself, okay, because any prime number factor has to be less than or equal to the number. So they couldn't have been factors since these prime numbers weren't factors. Okay? So that leads to this result. We only have to check a number is divisible by any prime numbers whose square is less than the number given. Okay? And this is for checking for prime numbers, which is a little bit different from the factor pairs. But let's build on it. So with the factor pair, since this was 89, we had to check up to 9 because 89 falls between 81 and 100 and we round down. Since we're checking to see if it's prime or composite, we don't need to find all the factor pairs, we just want to see if it's a factor. So we didn't need to check any non-prime numbers less than 9. So 8 is not a prime number. 7 is, we didn't have to check 9, sorry, 9 is not prime. 7 is prime, so we had to check it. 6 is not prime, did not need to check it. 5 is prime, check it. 4 is not prime, 4, so we don't have to check it. And we had to check 2 and 3. So, needed to check 2, 3, 5, and 7. Just the prime numbers less than 9. Okay? So that's going to be our strategy, and that's basically what this sentence says. So let's try the next one, and we're not going to do all the extra steps we don't need to do. Verify that the following number is prime. We have 137. So let's locate it in our chart. 137 is between 121 and 144. Rounding down, we'd go to 11. Okay? So we only need to check the prime numbers less than 11. 2, 3, 5, 7, and 11. We don't need to check 4 or 6 or 9 or 10, just these 5 numbers. So let's write them down. 2. So put a 2 and a question mark. 137 isn't even, so it's not going to be divisible by 2, but we can check it anyway, and our answer is no. Is 3 a factor of 137? Well, let's divide 137 by 3. There's a decimal, which means there's a remainder, so 137 is not divisible by 3. Now we don't need to check 4, we need to check 5, because 5 is prime and 4 is not. 137, it doesn't end in 0 or 5, so it's not divisible by 5. There's a decimal, which means there's a remainder, so we can cross out 5. Now we only have 2 numbers left to check. 7. 137 divided by 7. Notice there's a remainder, so it's not divisible by 7. 137 is not. And now the last number we need to check is 11. 137 divided by 11. There's a decimal, which means there's a remainder, so it's not divisible by 11. So since 137 is not divisible by any prime numbers whose square is less than the number given, namely 137, that means that it's prime. So we have verified that this number is prime. Okay? And notice how great that really is. 137 is a rather large number. We only had to check to see if it was divisible by 1, 2, 3, 4, 5 numbers. We didn't have to check all the way up to 137 because we learned the square rule. Okay, so that made us only check up to 11. And now, since we're just checking for primality, which is one way we say whether the number is prime or composite, we don't even have to check all of the numbers that are composite less than it. We only needed to check the prime numbers whose square is less than it. Let's try one more. Now we have 163. Now let's find 163 would be between 12 and 13, so rounding down, we would be here. Okay, but we only need to check the prime numbers less than 12. So again, we only need to check up to 11 and only prime numbers. So 2, 3, 5, 7, and 11. Okay. So it doesn't end in an even number, so it's not divisible by 2. 2 is not a factor. Okay, you can check that on your calculator if you don't believe me. 163 divided by 3. Decimal means there's a remainder, so it's not divisible by 3. Next we have to check 5. We can skip 4. 163 and oops, notice it doesn't end in a 0 or 5, so it's not going to be divisible by 5. Okay. So notice 2 and 5 are pretty straightforward to figure out or cancel out without even dividing. Not even doesn't end in a 0 or a 5. Okay. Next we have to check 7. 163 divided by 7. Remainder because there's a decimal, so that's not a factor. And finally 11. 163 divided by 11. There's a decimal, which means there's a remainder, so 11 is not a factor. So since none of these prime numbers whose square is less than the given number is a factor of 163, we have determined that 163 is prime. Okay. So that is our method for determining whether a number is prime. You look at the number, you find the square that's just less than the number, the two squares it lies between. You look at what that number is squared and you check all the prime numbers less than that number.